Okay, so right now we've got both boxes running. We have the set point of the ale box at 70 degrees, and we have the set point of the lager box at 40 degrees. I've got an infrared sensor gun here to show us the temperatures around the room and of the heating and cooling units. So right now, the ambient temperature of the room is about 44, 45 degrees. Get it? And come over here. As you can see, the heating element is working and it's on. The gun's reading 178. So that heat, as it emits heat, it'll fill up the space inside here when it's sealed shut with that heat. And once our temperature sensor mounted inside senses that the temperature inside is 70 degrees, then the heating element's going to shut off. This heating element is, the motor output is controlled by pulse width modulation, which senses the temperature and compares it to our set point temperature, and then determines the amount of error between the two. And based upon that amount of error, that determines how fast the pulses are going to the heating unit. The more the error, the farther below the temperature we need, and the higher the motor output, and so it'll heat more to get it closer to the set point temperature. Once it hits the set point temperature or goes above it inside, then the heating element won't turn on at all. So onto our cooling box. We set the cooling box temperature at 40 degrees. The set point is 40, and the ambient temperature in there is about 42, 43. As you can see, if I flash it onto the cooling unit, it's showing 0 degrees in there on the cooling coils themselves. So once our temperature sensor, which is mounted on the other side of the box, senses that the temperature hits 40 degrees inside of the box, so it only needs to cool a couple more degrees, the cooling unit will turn off, the motor output to the relay will turn off, shutting off that circuit. This one does not use pulse width modulation because it just needs to turn on and off, and we didn't want to burn our compressor out. And that's our project.